We pick up this section talking about the calibration of dual pendulum dial scales. We use a couple of examples from our training room. This basically is a Blackline, old style, 3100 series. This bench scale is actually 125 pound capacity. In a few moments, we'll talk about just a couple of the adjustments in the head. What we're looking for in a scale is to create an error that is both linear and in the same direction. What do we mean by that? Well, if I have an error, for instance, that's +1 at the first quarter, +2 at half, +3 at the third quarter, and then +4 at full, those errors, that would be a linear error and in the same direction. The description in the same direction is applicable to the relationship to the error at full capacity compared to half capacity. We want that error to be twice as great and in the same direction. When we have an error that is very linear, whether it's plus or it's minus, it's really very easy to correct for. At this point in time, one of the things I normally ask people is, do they have a grandfather clock? You know, do they ever need to set the time on their clock? Is it running a little bit slow or running a little bit fast? In the business that we're in, the way that we would describe that, slow would be if the scale was in a minus condition or under registering, and we always talk about that error in terms of graduations, okay? It should be -1, -2, -3. You may describe an error as -1/2 of a graduation if you prefer. But because there's so many different capacities, charts, pounds, ounces, kg, and other units of measure, we always want to think and report errors in terms of graduations. That is a standardized for our department, our industry. That's just really the way that it should be. As well, something I've already said is when we test a scale, we normally want to make sure that we start from 0, and then we'll test the first quadrant. Half would be the second quadrant, third quarter would be the third quadrant, and then full capacity. Those would be the points that we would test at. Now, is it possible for a scale to have a problem somewhere else? Yes, absolutely. One of the things that I've noticed over the years is that on this old style series, about this point right here, you'll notice that the little latch is, you know, it may get pretty close if it's not adjusted either on this side or this side. So you'll notice you could easily have an error right around the first corner, the first quadrant, or the first quarter, and the rest of the scale might be fine. But if anything touches that's not supposed to in this head, you're going to have very, very serious issues. Okay, we've just described the old style, the Blackline, the round column, so to speak. And now, I apologize for walking in front of the camera. We'll kind of take a look at the difference. Would be a new style. It would be a 2000 series. It would be considered a gray line, all of those things. And you'll notice a square cabinet aspect instead of round. Now, there were a number of improvements made. There are an awful lot of similarities in the adjustments between the gray line or the new style and the black line or the old style. Right here, this dial was designed so that it could turn to front. You know, let me see, this is one position, 2, 3, 4, 5, 6. There are 7 or 8 actual positions that this dial could simply turn turn around and be in about 8 different positions. And one of the things that's a little bit different is you'll notice a bearing right here. I'm just taking this and spinning it right here, and the difference would actually be in this scale you'll see a yoke instead of that bearing. Another thing you'll see that's a little bit different is these would be considered the major weights, and this is the sector adjustment in the old style. The loosening of that bolt per se and the tightening or loosening of there are 2 screws here, that would be considered a sector adjustment. In the new style Toledo, the raising and lowering of this entire major weight by loosening a screw right here would be considered that same adjustment that would correct for a linear error, whereas a sector adjustment would be the loosening of this small bolt and sliding this and or this in or out just a little bit. And we always try to split the difference as far as when we make an adjustment, we try to make sure that the major weights are at the same level, and if we make a sector adjustment, okay, we're going to do half of it on one side and half of it on the other side. There are a couple of small or minor differences in the new style, but the pinion and the rack, and for the most part, the compensating bars, the compensating bar yokes, those are pretty much the same. Okay, I'm going to show one more difference. Excuse me. There's actually, this is a rail gauge, and one of the differences in the new style was that this gauge was designed to give you a consistent spacing, and when the scale pulls, it simply holds this here and the indicator is put on 0, and that's called a rail gauge, and it's a tool specifically designed to work with a new style or 2000 series scale. Going back to the black line or the old style, what you'll notice is that both of these major weights, we simply look at them and try to make sure that they're as straight up and down involved in the stroke of the scale, that both of these at 0 are as straight up and down as possible. Now, the reason that is important is because if they are straight up and down, we will be able to make a full capacity adjustment without affecting anything at 0. And that's really what we want. We want to be able to make that nice full capacity adjustment, set the indicator on full capacity, and hope that we don't have any interaction with 0.